Okay, so this is looking at finding a side. So the first thing I have to do before I find a side in trig is actually identify what I've got. So here I've got the opposite of this angle and I've got the hypotenuse. So if I write out the magic word SOHCAHTOA, I've got an opposite and a hypotenuse, so I know I've got to use my sine. So my sine of 35 degrees is equivalent to my opposite over my hypotenuse, which is the equivalent to x over 10. So sine 35 equals x over 10. If I multiply both sides by 10, it just becomes 10 sine 35 equals x. So that allows me to find that side quite easily by just producing the calculator. I'm not expected to know what sine 35 is, and I go 10 times sine 35, close brackets, and I get a really stupid number. I'm going to say 5.7. So x equals 5.7. Okay, so this will work exactly the same if it's cosine or tan. So if it's cosine, then our x would be here, our 35 would be here, and our 10 would be here, and that would be my adjacent, and that would be my hypotenuse, and my cosine of 35 would equal x over 10. X would equal 10 times cosine of 35, which would equal 10 cos 35, and I've got 8.2 because I'm going to round to one decimal place. And if it's tan, I've got an adjacent here. My adjacent is 10, this is 35, this is x. And with this one again, so this is tan 35 is x over 10, x is 10 tan 35, so x is 10 times tan 35, close that bracket, failed to close that bracket, and it's 7.0 to one decimal place. So here, doesn't matter whether it's sine, cos or tan. If the side we're looking for is on the numerator, it's relatively straightforward to do. You just multiply your sine, cos or tan by the denominator. You just do a little bit of rearranging. What happens when it's this way round? Now, I've got 35 degrees here, 10 here, and x. Sorry, you can't see that 10 there in x. So there's my hypotenuse, and there is my opposite. So just like before, it involves an opposite and a hypotenuse. So if I write out SOHCAHTOA, I can see it's an opposite and a hypotenuse, so it's sine. So the sine of 35 is 10 divided by x. And we'll notice now our side is our denominator. So our side is our denominator. So if I multiply both sides by the denominator, I get this, which doesn't feel that helpful, but it has got rid of that fraction. So I now need to do another stage, which is, so I've multiplied both sides by x, and now I'm going to divide both sides by sine 35. And that gives me x is 10 divided by sine 35. And again, I'm going to take my calculator and I'm going to go 10 divided by sine 35, close brackets. And that gives me 17.4. X is 17.4. So what have we learnt? Well, if we have the numerator, it's just a one-stage rearrange. But if x is on the denominator, it's a two-stage rearrange. It's a little bit more thought. So that's why you need to be careful with these. You either have, so if x is on the numerator, it is a one stage rearrange, and if x is on the denominator, we have two stages to rearrange and make x the subject. So what you've got here is you've got to look at where the x is. It doesn't matter whether it's sine, cosine or tan, the rearrangement thing will work for that. And just to check that I'm speaking the truth, we'll try this with a cosine version. So that means our adjacent has to be 10. That's x, so that's a cosine because it involves a hypotenuse and an adjacent. So cos 35 is 10 over x. So x cos 35, I've multiplied both sides by x. You don't need to write that down in an exam, but if it helps you, do. Then I'm going to divide both sides by cos 35. And I'm going to get x equals 10 divided by cos 35. Then I produce my calculator. 10 divided by cos 35 gives me x equals 12.2. Okay, hope that helped.